Okay, number 31 here. You're asked to find the area of a rectangle, and you're told that one side is 3 times the other. So that's their way of saying you don't know what the sides are, but they give you a little bit of a clue. The way we indicate that is one side is x, and then if the other is 3 times that, then the other side is 3x. My goal is to find the length of this side and the other side so that I can find the area. We're going to use the Pythagorean Theorem here because there's a built-in right triangle. So when I do the Pythagorean Theorem, I get x squared, that's this squared, plus 3x squared, that's this whole side squared, and I need to write it that way because otherwise I'm not going to include the 3. And then the last side, this is the hypotenuse squared, 3 root 10 squared. Okay, now let's simplify a little bit. X squared, there's nothing I can do with that. When I square this, I need to square the x and the 3, so I get 9x squared. And over here, same thing. I need to square the 3, that gives me a 9. And I need to square the square root of 10. When I square a square root, it just goes away, the radical goes away. So I just get 10. Okay, so on this side here, I have 10x squared. I had x squared, and then I had 9 more x squared. To put them together, I have 10 total. And then on the right side, I have 90. Now we need to solve for x. Let's divide by 10. X squared equals 9. Now I take the square root, and we only want the positive square root because we're dealing with the length of a rectangle, so x equals 3. Okay, we're not finished yet because what we want is the area. Now it turns out if x is 3, that means this side is 3 and this side is 9. So the area is base times height. The base is 9, the height is 3, so I get 27. Okay, that's the area of that rectangle. Okay, moving on to number 33. We have a rhombus, and we're told, well, rhombus is like a square where all the sides are the same, but it's also a parallelogram where you have the sides slanted, so you don't have right angles at the corners. Another feature about a rhombus is that the diagonals, when you put the diagonals in, you get a right angle in the center, and you also get the feature that the diagonals bisect each other. So this length is the same as that, this is the same here. We're also told in this problem that the diagonals have length 24 and 10. So let's make the longer one 24. This whole thing here is 24. And this one here is 10. The picture's a little messed up now, but what I really care about is this half here. If they get divided, it was 24, so this must be 12, and this one here must be 5. Now, the problem's asking us for the perimeter, which means I need to add the lengths of the outside. So I don't know what that is yet, so let's call them all x. The nice thing about the rhombus is that you create this right triangle inside here. So if I look at this little triangle, it's like so. With a right angle, this is x, this is 12, this is 5, and now I can use the Pythagorean Theorem to find x. So 5 squared plus 12 squared equals x squared. This is 25. This is 144. So I have 169 equals x squared. And again, when I take the square root, I'm looking for the positive square root, which is 13. So now I know x. The perimeter, that's where I add up all the lengths of the outside. So I have x plus x plus x plus x. That's equal to 13 plus 13 plus 13 plus 13, and that's equal to 52. So there's your perimeter right there.